The Life and Death of a Star by Tyler Mizera, Katie Dickert, and Stephen Murdock.
We interviewed various students around Ohio State's campus, and here's a bit of what they had to say about how stars are formed. How do you think stars are formed?
Well, from what I understand, stars are formed by different particles and clouds of dust in space that form together and create really dense areas of mass, and that is where we see them. They have a lot of energy and they're really hot, and so that's why we can see them from Earth.
How do you think stars are formed?
I think stars are formed when clouds of dust particles and gases start spinning really fast and then condense into a ball. And then as the ball of dust and gases ages, it burns out a lot of energy and then eventually it explodes because there's no more energy left.
Stars take about 10 million years to form, depending on their mass, and the process begins inside molecular clouds made up of interstellar gas and dust. Molecular clouds have a temperature just above absolute zero. In these extremely cold conditions, the atoms and gases form molecules, most commonly CO and H2, and also the gas clumps to high densities. When the density reaches a certain point, part of the cloud core collapses due to gravity. While this is happening, the cloud starts to spin faster, heat up, and flatten out into a disk. The cores break into clumps, and these clumps form protostars. As the cloud becomes smaller and faraway mass moves closer together, gravitational potential energy is converted into kinetic energy, also known as temperature. Once the temperature in the core reaches 1 million Kelvin, fusion begins. When the thermonuclear fusion of hydrogen to helium in the core becomes stable, the star officially receives its.
Once the star is formed, planets form solar systems around the star through the leftover material from the star formation, through processes such as accretion or gas capture. Once the planets have formed, they orbit the star in elliptical motion according to Kepler's first law, with the star at one of its focuses. Due to the high temperature in a star's core, they produce their energy through the process of hydrogen fusion as they travel along the main sequence of stars. This process can last for hundreds of millions of years. Once again, we interviewed various students around the Ohio State University's campus, this time asking them about the process of nuclear fusion.
Oh, hello. I guess I didn't hear you come in. I was just Googling some nuclear fusion. From my understanding, nuclear fusion is the fusion of two life forms.
To me, nuclear fusion is, I would assume it's something to do with the atoms and creating energy that's creating energy. I would assume.
Nuclear fusion, or more precisely the process of hydrogen fusion, is when two hydrogen molecules fuse together to form a new molecule and energy. This is a very complex process and we will not be able to go into very much detail. The energy a star produces through hydrogen fusion is transmitted via light, the universal messenger. Some of these planets that form an orbit around a star could exist in the habitable zone, a zone in which a planet has the ability to support liquid surface water. The habitable zone is an area in which planets orbit not too far away from the sun, in which surface temperatures would be so low that all liquid surface water would freeze, but also not too close to the sun, in which all liquid surface water would evaporate. Due to the fact that stars are the main source of energy in the universe, they are essential for life, because all life requires energy.
Once again, we interviewed students, but this time pertaining about the death of a star.
So how do you think a star dies?
A star dies, doesn't it, it collapses on itself and then goes supernova, right? And it turns into a black hole.
So how do you think a star dies?
I have no idea.
Oh.
When a star like our sun has burned all of its hydrogen fuel, it starts to expand into what is called a red giant. The sun at this point is capable of swelling up by millions of kilometers across, which is big enough to swallow planets like Mercury and Venus. After expanding off its outer layers, the star begins to collapse into a very dense white dwarf over billions of years. The white dwarf begins to cool down and become invisible. Stars that are much heavier than our sun end their lives much more quickly. When they run out of fuel, they expand into red supergiants. Red supergiants try to keep alive by burning different fuels, but this can only sustain them for a few million years. Once out of fuel, they blow themselves apart in massive supernova explosions. What's left behind is a tiny dense object, a neutron star, or a black hole surrounded by a hot cloud of gas. Due to the violent nature of dying stars, most planets are either consumed by the star expanding or destroyed when the star goes into a supernova. On the other side of destruction, there is also new life. The hot expanding cloud of gas forms the base that is needed for new planets and stars to form, and with new planets comes the possibility of new life.
We created this video to help inform our fellow students about the life cycle of a star, something that most students seem to be unaware of. Thank you for watching.